Right, welcome back to our other example of analyzing using chi-square hypothesis test um, through the applications of contingency table. Right now, the purpose of using contingency table is to analyze whether there's any relation or correlations between two attributes or two variables, okay, or whether the two variables are dependent or are they independent to each other. Okay, now for this question, a researcher wanted to study the relationship between gender and owning cell phones. So she took a sample of 2,000 adults and obtained the following informations, and then she has already put it into the uh, table form. All right, so it's a 2 by 2 table. Now the main task or the question that we need to answer here would be, at the 5% level of significance, can we conclude that gender and owning cell phone are related for all adults? Okay, so are they independent or are they dependent? Okay, now first of all, we're going to start off by, okay, uh, now of course, to analyze the information from a table itself. Right. Now, averagely, we can say that 50% of the women would own cell phones, and then the other 50% does not, whereby there's a higher percentage of male owning handphones as compared to them not owning any cell phones. Now, then again, this is just a sample that we have collected. Right? So the first step here is to write down its um, hypothesis statement here. Right, now let's write down the hypothesis statement. That will be H naught. Okay, we will say that gender and owning a cell phone um, are not related. Okay, are not related for all adults. Okay, which mean they are independent. All right. Now, whereas the alternative hypothesis would state otherwise, it would state that gender and owning a cell phone are related. All right, now that's our first step. I hope that is clear. Okay. Now the second step is to calculate the expected frequency. To do that, you have to determine the total for each individual rows and each individual columns. Okay, now here I have already done that for reference. So we get the total up like 600 plus 440. We will get the column total here. And then we have to repeat that same routine to obtain the row total. Okay, now that will be here. This is 1080. Okay, this part here is 920, and then here you can see that it's actually 1090, 910, and then all of them should total up to 2000. Okay, so the second step is to calculate the total for all the rows and columns, and then after that we are going to determine the expected frequency, or in this case you can use FE here. Right. Now I'm going to show you two example how do we calculate the expected frequency. So the first one, we get to calculate the expected frequency for men who own cell phones. That would be, all you need to do is just take the total here, 1080, by the total here. So we have to take this total, multiply with this total here. We have 1090, and then divided by the overall sample. Okay, now that will yield the expected frequency for men who own cell phones. Now you can repeat the same procedure for men who does not own cell phone. That will be 920, which is this, by 1090, and then divided by 2000. Okay. And then we're going to repeat that for women who own cell phones. We're going to obtain the expected frequency for women who own cell phones. And then we're going to calculate that um, expected frequency for women who does not own cell phones. Okay. Now I have already done that. I'm going to show you the result of this. Okay, this is what we have. Right, just let me clean this up. And then there you have it. This value here is for expected frequency for men who own cell phones. This is the expected frequency for men who does not own cell phones. This is the expected frequency for women who own cell phones. And then lastly, we have the expected frequency for women who does not own cell phones. Okay. And then step number three. Step number three, we will have to calculate the observed chi-square value. So the observed chi-square value is calculated based on this formula here. Okay. And then that would translate to, okay, I'm going to show you all its individual calculations here. Okay, now that's the first chi-square. Second one, I forgot to square that. And then after that, we can repeat that for a woman. There's a 1 there. Okay, 491.4. Okay, just let me erase that so that is clearer. Okay, that is 440 minus 491.4 here. Okay, and then lastly we have 470 418.6 square by 418.6 there. Okay, and then finally we're going to tabulate the sum of this, which I have already calculated as 21.4 here. Okay, and then there you have it. That is the observed chi-square value from the sample data that we have collected. Now, the fourth step is to compare this observed frequency with, observed chi-square value with the critical value. So so we have to obtain its critical chi-square value from the data booklet or from any software which can calculate the critical chi-square value, right? So here I'm going to bring up my data booklet. You can use any data booklet that will give you the chi-square uh, value tabulation, right? Okay, now our test is valid at 5% level of significance. Okay, and then the other information that we need in order to use this table or to determine the critical chi-square value is its degree of freedom. So the degree of freedom, um, here I write down degree of freedom as V. Now the formula is given by R minus 1, C minus 1, where the R is the number of rows, the C stands for number of columns. So in this case, it's a 2 by 2 table, so it's quite easy to determine that its degree of freedom is 1. Now all we need to do is go to the row that's that degree freedom of 1, and then at 5% level of significance. So 5% refer to a rejection region of 5%, whereby the confidence levels will be 95%. So here we are supposed to refer to 95%. Okay, so this is 95%, and then that will yield um, our critical chi-square value. So the critical chi-square value that we have already obtained is 3.841 here, 3.841. Right? And then we know that we know that the observed chi-square value is much more greater than the critical chi-square value. It's much more greater than the critical chi-square value, right? Now, therefore, this observed chi-square value fall in the rejection zone. Now, we have sufficient evidence to reject null hypothesis. Therefore, we can conclude that gender and owning a cell phone are related. All right. Now, I hope that is clear to all of you. Okay, how we actually apply chi-square um, hypothesis test using contingency table to study the independence between two attributes. All right. Now, this is the end of this question here. I'm going to move on to the next example shortly. All right. Example number 4. The management of cinema takes 150 randomly selected questionnaires and records whether those patrons enjoyed or did not enjoy the horror films and action movies. Okay. Now all these informations has been recorded in the table below. All right. You can see that all these observed frequency for customer or patrons who enjoy action movies or those who enjoy the horror films or may not enjoy horror films. Right? Okay. Now at 10% significant level, are we able to, or do we have sufficient evidence to conclude that the enjoyment of two types of movie is independent? Right. So we're going to test this out. Okay. So first step is always the same, to write down the null hypothesis. So we will say that the enjoyment of enjoyment of two types of movies is independent. All right. Whereas the alternative hypothesis would state otherwise, of course. The enjoyment of two types of movies is dependent. All right. Now we have a clear objective now. Now step number 2, as I mentioned before, we have to tabulate its total here. The total for the row and the column. Okay. Now which we have done that here. And then the next step is to calculate its observed chi-square value. So its observed chi-square value is tabulated again. I'm going to reiterate this formula again and again. It's given by this. Okay. Now, before we can calculate this, of course, we have to determine its expected frequency. Okay. So by using all this total here, we're going to determine its expected frequency. So here I have already tabulated the expected frequency. Okay. Now I hope that you still remember how to tabulate the expected frequency. Here I'm going to review that one more time. To calculate the expected frequency for the first cell here, we will take the total here. So we'll take the total here and then multiply with this. So we'll take this total, multiply with this total, and then divide it by 150. So that will be 66 here by 92 divided by 150. Now that's how we calculate the expected frequency for the first cell. And for the second cell, the same routine. That will be 84 by 92 divided by 150. Okay. Now from here, I have already tabulated all its individual expected frequency here. All this for. Okay, so take a look and then make sure you are able to obtain the same expected frequency as what I have obtained. All right. So once we have obtained this, we can calculate its observed chi-square um, value. So the observed chi-square value would be, we're going to write this one out explicitly. So that will be 51 minus 40.48 square. And then we have the second one. The order how you sum up the chi-square is not important, but the sum is important. So, okay, 52, and then we're going to continue on with 1525.52 divided by 25.52, and then lastly we have. All right. Now, don't forget, even though I'm using a software here, if you are sitting for exam, you have to show all these step. You have to show your hypothesis statements, and next you have to show how do you calculate your observed chi-square value. Um, Now, from the all these calculations, you should be able to obtain your observed chi-square value as 12.6, right? Or 12.626 in this case, right? Okay, and then there you have it. The next step is to determine its critical chi-square value. To do that, we have to determine the degree of freedom. Now, then again, this is a 2 by 2 table, so therefore the degree of freedom must be a 1, and then the significant level is 10%. Bear in mind this is a right hand side tail, so therefore the right hand side or the rejection region would represent 10%. So let me get the data booklet, okay, so that we can obtain its critical value. Okay, all right, so this is our data booklet. Okay, based on these two informations, we're going to look under this table for the column that says 90%, 0.90, because this region is rejection region is 10%. So this part must be 90%. So we're going to look at under 90% degree of freedom of 1. Now, the critical chi-square value, therefore, from here, we would be able to obtain its critical chi-square value as 2.71, for instance. Okay, so 2.71. Now, from here, it's quite obvious that, okay, if I were to draw the chi-square distributions curve one more time, you will see that uh, the critical chi-square is over here, whereby the observed chi-square is somewhere here. So the observed chi-square is somewhere here, which means the observed chi-square actually fall in the rejection rejection region. Therefore, we will have sufficient evidence to reject our null hypothesis. Therefore, we can conclude that the enjoyment of the two types of movies um, is dependent. All right. Now, I hope that is useful to your learning. For example 4, I'm going to go to the last example shortly. All right, final example for today. Okay, let's go through example number 5. Now we are given a 4 by 3 contingency table as shown below here. Now the informations recorded represent the, I would say, the types of cars, and then the age of driver. Okay, now you can see that from the table here, right? Now, the first question. So here we have a few breakdowns of the question. Write down the appropriate hypothesis for a test to investigate whether type of car, and owner's age are independent. Yeah, okay. Now, as usual, we are going to write down our null hypothesis. So we will say that the type of car and owner age are independent. So they are independent, whereby the alternative would state otherwise. So type of car and owner age are the are dependent. Okay, and then there you have it. That's our first question. Okay, so I hope that is clear. Now, second one, we need to calculate the expected frequencies, assuming that the null hypothesis is um, true. Yeah, okay. We always start with our first assumptions that the null hypothesis statement is true until proven otherwise. Okay. Now the expected frequency. Now, as usual, before we start with the calculation, before we start with calculating the expected frequencies, we need to determine the column totals and the row totals, which has been done for us in this case. Therefore, we just need to use the same formula to obtain its expected frequency here, each one of them. So here I have already calculated here. Oops, sorry, it is supposed to be this one, here, here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 sets of calculated expected frequencies. Okay, now that has been done for you here. Now, of course, in the exam, you have to calculate that manually using your calculator, right? So I hope that is clear. Just let me erase this. I'll just show you how do we calculate it manually. For instance, number 2. To calculate the expected frequency for this one here, we will use 68 by 134 divided by the total 360 here. So this is number 1 here. And then for the number 2 here, for instance, okay, so number 2, we can calculate that using 184 by 134 divided by 360, and so on and so forth, until you are able to obtain all these individual expected frequency. Okay. All right. Do take out your calculator and then tabulate that and check on your own. All right. Okay. You can check that through. I'm going to pause here. You can check on your own each one of them and then to see whether it tally. All right. So if you're satisfied with this expected frequency, all right, now we are done with the first one, second one. Now the third one, to calculate the value of the test statistic chi-square. Yeah, the test statistic chi-square is also known as the observed chi-square. So we're going to calculate the test statistics chi-square here. Okay. So the test statistics chi-square, again, the formula is given by this. And then you can tabulate each individual chi-square value here. So I'll just show a few, and then we're going to sum it up shortly. So here, the first few cells will look something like this, divided by 25.311. And then after that, this is my first one, this is my second one, for instance, 67 minus 68.489, for instance, divided by 0.489. And then you're going to sum that up. You're going to sum up all the 9 sets of chi-square values. Okay. Now here I have already calculated each individual. So let me show it to you. This is how it looked like. So each individual calculations of the chi-square here. 1, 2, 3, 4, 5, 6, 7, 8, 9 here. And then we can tabulate its total here. This is this and this. So this total will be here, this total will be here, this total will be here. And then finally, oh yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry, there are 12. I missed out, there's another 3 down here. So there will be another total here. And then therefore, the total for the test statistics chi-square value would be, all you need to do is just sum up all this value here. I have already determined the chi-square here. Just let me see whether I have the value. 66.75 approximately. 66.75. So 66.75. Now that will be our test statistics chi-square value, or the observed chi-square value. All right. Now I hope that is clear. Okay. Right. Now number 4, we need to find the critical value, the critical chi-square value at 5% significant level. Now we will need our data booklet here. Just let me get our data booklet. Where is that? Okay. Here you are. Okay. So first of all, for number 4 here, we need the degree of freedom because it's a 4 by 3, so therefore it's 4 minus 1 by 3 minus 1 here. So that will be a 6. Now the degree of freedom is 6 at a significant level of 5%. So this is 5%. We are supposed to look for 95%, and then under degree of freedom 6 here. So that would actually yield the critical chi-square value of 12.59. Now I hope that is clear for question number 4. Okay, now number 5 is just to complete the test, meaning that we're going to compare both the test statistic chi-square value with its critical chi-square value. Okay, now it's very obvious that the critical chi-square value is less than the test statistics chi-square value of the observed chi-square value. Therefore, the test statistics chi-square fall in the rejection region. Okay, so to complete the test here, we can write that down as the test statistics chi-square is much more greater than the observed, the critical chi-square value, which is 12.59. So this is one of the conclusions you must make in the exam. Okay, and then finally, I'll comment on how the ownership of different types of car depends on the age of the driver. So because it falls in the rejection region, we have sufficient evidence to believe that we can reject our null hypothesis. Therefore, the ownership of different types of car actually is dependent are dependent on the age of the driver or the owner. All right. Now I hope that is clear to you. All right. Now that's our final example on how to use chi-square using contingency table here. All right. Okay. Thank you for watching again. Don't forget to click the subscription button and the notification bell to receive the latest video that I will upload. All right. Thank you very much for watching.